Right, so today we're going to be looking at roots of quadratic equations. Right? Now, very simply, the answers to an equation are called roots, right, or solutions sometimes. Okay, and actually quite easily to visually demonstrate that, we could either draw a straight line, and the solution or the root is the point at which the line crosses the x-axis when y is equal to 0. The same thing with a quadratic. So if we had to draw a quadratic, right, the points that the quadratic intersect the x-axis are what we call the roots or the solutions to the equation. Okay. Now, we learned back in IGCSE that if you want to find the roots, we can use the quadratic formula. And here we have the quadratic formula. So let's consider three different quadratic equations and look at their roots that come out. And we can use that to come up with a theory. So using the quadratic formula on the first one, we can see we can have minus 2 is b plus or minus the square root of b squared, which is 2 squared minus 4, a which is 1, c which is negative 8, all divided by 2 times 1. Okay, and simplifying that, we're going to get x equal to minus 2 plus or minus the square root of 36 all over 2. Now we can take our two solutions. So we'll, on this side, we'll consider the positive and this side the negative. So we'll get negative 2. The square root of 36 is just 6. So we'll have negative 2 plus 6, which is 4 divided by 2. So we'll get x equal to 2. Or we can get x equal to negative 2 minus 6, which is minus 8 divided by 2. It gives me minus 4. They are my two solutions. Okay, let's do the next one. So the next one will have minus 6 this time, plus or minus the square root of 6 squared, minus 4 times 1 times plus 9, all over 2. And we'll get x can be equal to minus 6, right? We have 36 minus 36, so we'll have the square root of 0 plus or minus divide by 2. So here again, we could technically consider the two possible solutions, right? Because there's plus or minus the square root of 0, which is going to yield the same number. And so we're going to get two solutions at negative 3. Right? So we'd have two equal roots, as we would say. Right, let's have a look at the last one. We have minus 2 plus or minus the square root of 2 squared minus 4 times 1 times 6. That's going to be over 2 times 1. And so x would be equal to minus 2 plus or minus the square root of, that's going to be negative 20 all over 2. So here we have a square root of a negative number. And so we can say that we have no real solutions, right? Because we don't have any solutions in the real number world. Okay, we would have imaginary solutions, but those are not the ones we're interested in. So we've made some clear observations here, right? If we have a look at the number under the square root, when it was positive, two distinct roots. When it was equal to 0, we got two equal roots. And if it was a negative number, then we got no roots. Now, the important thing to note here is where this is being made, right? And we can see that the results of our solutions are being affected by what's underneath the square root, okay? Because if it's a positive number, we'll get solutions. If it's a negative number, we wouldn't get solutions, okay? And so this is what we call the discriminant, okay? So everything under the square root is b squared minus 4ac, right? And depending on the value of the discriminant, we've been able to observe we get certain solutions, okay? And so one of the most important things to remember about the discriminant is if b squared minus 4ac was a positive number, okay? In other words, if it was greater than 0, we saw that we would get two real solutions. And then we noted if we had b squared minus 4ac equal to 0, we would get two equal solutions. And finally, if b squared minus 4ac was less than 0, if it was a negative number, we would get no solutions. And so we can use the discriminant to determine the number of solutions that a quadratic equation might have. Now, a visual way to represent this, if we have the discriminant, and let's for instance say that we have the discriminant is greater than 0, we saw that we had two real roots, and visually that would look something like this. Okay, you can see that we have two intercepts on the function on the x-axis, and those are our roots. Okay, and that would mean the discriminant was greater than 0. Then we saw if we had the discriminant equal to 0, we said we had two equal roots. In other words, the roots were happening at the same time. And that would look something like this, right? So we can see that we have one intersect, right? Actually, we have two, but they are the same, so we can actually just say that it's one. And finally, if the discriminant is less than 0, it means we had no solutions. And visually, that can be represented like this. So it's a function, right, or a quadratic function where the curve does not intersect the x-axis, right? So there's no solutions for this quadratic, right? So that's what these look like visually. Okay, let's see where we can use this to answer questions, okay? So the question says, find the values of k for which x squared minus 3x plus 6 is equal to kx minus 2. And they say we want to find the values where this quadratic has two equal roots. Now, first of all, when we use the quadratic formula, it needs to be in the form ax squared plus bx plus c. Right? And at the moment, our equation isn't like that. So we're going to have to manipulate it to change it into that. So we're going to get x squared minus 3x plus 6 equal to kx minus 2. So we'll expand all the brackets out. We'll get x squared minus 3x plus 6 equal to kx minus 2k. And what we're going to do here is we're going to group the terms based on their x coefficient, or even and the constant term by itself. So if I have a look in my expression, right, I can move the terms on the right-hand side to the left-hand side. Right, I'm going to put all the x terms together. So I've got this minus 3x, and I'm also going to put this term next to it. It'll become minus kx. Then I have this plus 6 over here, and I'm going to put this minus 2k because it doesn't have any x in it, and it'll become plus 2k on this side. And this is equal to 0. Okay, I'll do one last step, x squared. I'm actually going to take a factor of negative x out of this term, and I'm going to be left with 3 plus k, and then I'm going to put 6 plus 2k as well, just in a bracket. And now we can see that we have our a, which is just going to be 1. We have our b, which is the term in front of x, so there's our b. And finally, we have our c, which is everything that didn't have an x to begin with. Okay, so there's my a, b, and c. That's the first job that we had to do. Right, from here, we have to go back to the question, and the question said we want to know when this has two equal roots. So we know for two equal roots, b squared minus 4ac must be equal to 0. The discriminant must be equal to 0, because you could see when we solved this one here, when we got solution equal to 0, we got 2 equal roots. So the discriminant b squared, so what is b squared? Well, that's 3 plus k squared minus 4a is just 1, and c is 6 plus 2k. And this is equal to 0. And now this is just a standard quadratic equation which we can solve. So we'll expand the brackets out. 9 plus 6k plus k squared minus 24 minus 8k equal to 0. We can rearrange the terms. So we'll have minus 2k, and then we'll have 9 minus 24, which is minus 15 equal to 0. Factors of 15 are 3 and 5. So we'll have k minus 5k plus 3 equal to 0. So k could be equal to 5, or k could be equal to negative 3. Those are the values for k that would give us 2 equal roots. So if we substituted those values back in here, we would get a quadratic equation with 2 equal roots. And you can go and test that out for yourself. All right, let's look at one more example. Here they want to find the values for k again, for which there are 2 distinct roots this time. So the first thing we need to do is just manipulate the equation, or have a look if we need to manipulate the equation. Right, remember we want it in this form here, ax squared plus bx plus c equal to 0. So let's have a look. I have my a. They have already factorized the b for me, and here is my c. So I don't have to do any kind of manipulation this time. Okay, for 2 real roots, right, if we want 2 positive solutions, we saw that the discriminant b squared minus 4ac had to be greater than 0. So we will have k minus 2 squared minus 4 times 1 times 4 greater than 0. So k minus 2 squared minus 16 must be greater than 0. So this is just a quadratic inequality that we dealt with yesterday. All right, so we're going to solve this just like we would solve any other quadratic inequality. Okay, we're going to expand and factorize. K plus 4 minus 16 greater than 0. And just collecting like terms, we will get k squared minus 4k minus 12 greater than 0. Okay, from here, like with all quadratic inequalities, we're going to find the critical values. The critical values are the roots again, or the solutions when this inequality is equal to 0. So we're going to say k squared minus 4k minus 12 equal to 0. Let's factorize. K minus 6, k plus 2 equal to 0. So our critical values, right? Remember, these are not solutions. These are the critical values. These are the points that this new k quadratic intersect the x-axis. This will be at k equal to 6 or k equal to negative 2. And so we can quickly draw for ourselves a simple number line with negative 2 and 6. Draw our quadratic, and we want to know where all the solutions are. Positive, we want to know where they are greater than 0, and we can see that happens here and here. And so our answer would be that k could be greater than 6, or k must be less than negative 2.